Right, folks, so here we'll do question 4 and 10, differentiation, calculus, those sorts of style of questions. So the first one here now, work out the value of g of 5. So they give me a function g of x. To work out g of 5, the only thing you can do is horse in 5 for your x. So everywhere there's an x, throw in the 5. And just throw that all into your calculator. That's you showing the work. And when you do that, you get minus 57. Next thing, find g dash x. Now g dash x is the same as dy dx, the slope, the rate of change, and whatnot. So in this, what you've got to do is multiply down by the power, and then reduce the power by 1. So multiply down by the 3, you get 3x, reduce the power by 1, 3x squared. Next thing, multiply down by the power, 2 times 7 is 14x, reduce the power by 1, x or x to the power of 1. And when it says x, it's the same as plus 1x, 1x becomes plus 1, and your slope or your diff of a constant or a number is 0. So that's your answer. Everything changes. G dash of 5 is equal to 6. So that means if I threw in 5 into the x up here, I'll get 6. So it's a good way of checking. So if you did like 3 times 5 squared minus 14 times 5 plus 1, you should get 6. Usually you have to work out letters, and that'd be a good place to start. But it says, use this information to find the equation of a tangent. Now a tangent, if we have a curve, say there my x cubed, a tangent there, it just touches it at one point. So it's a line that touches that there at one point. So when they say find the equation of the tangent, they're slyly putting find the equation of a line. So if you look up your line formulas, you'll see the equation of a line is y minus y1 is equal to m times x minus x1. So the two things you need a slope and you need a point. When x is equal to 5. Now they've told me here from this information, they said dy dx is the same as slope. If I throw 5 into this, my slope is 6. So that's real tough there. So your slope is 6, your m is equal to 6. So that's my slope. I also need a point. A point's made up of an x and a y. I've got my x. To work out my y, I fill this in back all the way up to the top. Because that g of x is the same as saying y. Now f of x, g of x, p of x, whatever. That's the same as writing y. It's a function of your x. So fill in your 5 and up to the top. So to work out y, it's the same as 5 cubed minus 7 times 5 squared plus 1 times 5 minus 12. Now when you work that out, it's 5 cubed. Remember 5 to the power of 3, it's hard to see in that. 7 times 25 plus 5 minus 12, and you get minus 57. Oh yeah, we worked it out up here in the top actually. G of 5, y is equal to minus 57. That's why they wanted you to work it out, I suppose. So my point there is 5 and 50, or minus 57. And my slope there is 6. Now that is real tough, especially there for ordinary level. Label your point, x1, y1, my slope is m, and throw it into your formula. Y minus y1, y minus minus 57 is equal to m times x minus x1. Two minuses make a plus, is equal to 6x minus 30. Technically it says, write it in this form. What that form means is, get everything to one side. So, bring across my 6x and the minus 30, I get minus 6x plus y plus 57 plus 30 is equal to 0. Minus 6x plus y plus 87 is equal to 0. Tough, real tough question. B here, the graph of the function is shown below. U dash x is the derivative of the slope of a tangent. That's like realistically what it's telling you. Slope of a tangent line. Using your graph, write down a value of x for which the slope of a tangent is negative. Now, a slope of a tangent, if I was to draw my tangents to the curve. So I'll get the red pen out here now. Here, or here, or anywhere along there, you can see my slope's going uphill. So that's positive. So that's no good. You need to be able to draw a slope or draw a tangent where the slope's negative. So going down the way. It's hard drawing on this bloody thing. But anything after, say there, x is equal to 6, gets you a negative slope. It's going downhill again. Anything after there, x equal to 6, or x is bigger than 6, anything over there, it's going back downhill. So I would say a value of x, I'm just going to plump in x equal to 6. Now they'll give you a range of values, 6, 7, 8, 9, 10. Anything there, as I say, it's going downhill from here now. Like this question will work for you. On the diagram, draw a tangent, so draw a line. Draw a line at the point 42. So there's the point 42. Now get your ruler out. I have no ruler. Try and touch it only at one point. So there's my tangent line. I'll label it part 2. At the point 42, and use this tangent that you draw to work out the estimate for u dash of 4. Now u dash just means the slope. So we have to work out the slope of that red line. Now to work out your slope, if you write down the slope formula, y2 minus y1 over x2 minus x1. Or if you're good, you'd be saying rise over run. Now even this requires a very good student. So take 2 points on that line. There's 1 maybe for me, 2 and 0.5. And another point on that line, say 5 and 2.8. I know they'll give you a range of answers here. How do we label our point? x1, y1, x2, y2, and throw it into your slope formula now. And when you throw that in, you get 2.3 over 3. It's giving you a slope of 0.77 approximately. You know, but you might be neater in your formula books. Anything around a half, I think it was. They accepted there. And the other question there was question 10, because it was concerning differentiation, calculus, functions. You know, so studying kind of like questions. So Keith plays hurling. During a match, Keith hits the ball with his hurl. The height of the ball can be modelled by the quadratic function. Now, I'm a big believer in labelling what h is. So that's the height there. The height of the ball. H is the height of the ball in metres, just in case the units. And t is the time in seconds. How high was the ball when it was hit? So when t is equal to 0. So the initial height, they often don't give you the t is equal to 0. So if they said the initial height, you're throwing in t is equal to 0. So minus 2 times 0 squared plus 5 times 0 plus 1.2. You need a positive answer here, and then you'll get it 1.2 metres. The ball was caught after 2.4 seconds. How high in metres was the ball caught? So once again, they give me a time. I see there, once they give me a time, I fill it in for t. So the height is equal to minus 2 times 2.4 squared plus 5 times 2.4 plus 1.2. Throw that on your calculator and you get 1.68 metres. 1.68 that says. Next page. When the ball passed over the halfway line, it was at a height. So not after so many seconds, we have a height of 3.2 metres. And the height was decreasing. So we see, like, this is based on a quadratic function. And anytime we get a minus x squared or a minus t squared, it's an end shape. So it's on this second half, and it's decreasing. It's gone over the initial height, and now the ball's going down. How many seconds did the ball pass over the halfway line? And remember there's our function. So here the height is 3.2 metres. So instead of my h, I'm going to sub in 3.2. And I'm trying to work out the time. So if we're working out the time, we need to keep t into it. It's starting to look like my trinomial or quadratic. I'm going to bring everything over to this side, keep it positive. 2t squared. 2t squared minus 5t 3.2 minus 1.2 is plus 2 is equal to 0. Do your minus b formula. Open up your brackets, whatever you wish. I'll do my minus b because that's the way I teach you. And throw that into my minus b. Now I'm running out of room here, so minus b plus or minus square root of b squared. Your brackets are crucial. Minus 4ac all over 2a. When you throw that in, you'll get two answers. You get t is equal to a half and t is equal to 2. Now, it has to be the bigger value here. It does say after how many seconds. It's true enough, it happens after half a second, say there, and 2 seconds. But because it says the height's decreasing, now that might only be worth a mark. You know, you might have got 9 out of 10 if you didn't specifically say your t is equal to 2. Because it's decreasing and it's on the downward slope. And last bit here, find dH/dt, same as my dy dx technically. So we'll do that, multiply down by the power. So remember your h there is just minus 2t squared plus 5t plus 1.2. So multiply down by the power, reduce the power by 1, minus 4t plus 5. And find how long it took to reach its greatest height. If you ever say greatest, maximum, minimum, you diff it and you let it equal to 0. So minus 4t plus 5, let that equal to 0. So always at a maximum or a minimum or a turning point, generally I'll say dy dx equal to 0. Gets your attempt marks. Working out t, keep her positive, keep her happy. And t is equal to 5 over 4. So 5 over 4 or 1.25 seconds. And that's it. Oh no, it's not. Later in the game, Keith hit the ball again. This time, height of the ball after his hit could be modelled by a different quadratic function. So once again, it's going to be a minus quadratic function. This time the ball was 1 metre high when Keith hit it. So when he hit it, your point there is 0, 1. Its greatest height was 5 metres, which it reached after 2 seconds. So after 2 seconds, 5 metres, hit the ground without being caught. Find the other point. Now it's going to have a symmetrical feel about it. So it went 2 across there, 2 across, and it went up 4. So the next thing we're going to go 2 across and down 4. It's the greatest height there. Its greatest height was reached. So 2 across from 2 is 4, 1. Perfect time in the bell.